So in part 1 we discussed converting between the moles and grams. In part 2 we will be discussing converting between moles and liter. We are going to solve all these problems in part 2. That means the relation between the moles and liters. We have to convert moles into liters and liters into moles. The first problem, what is the volume in liters of 3.80 moles of carbon dioxide gas at STP? So now we have to find the volume in liters. So it was given as a moles. First of all, what do you mean by an STP? So STP refers standard temperature and pressure, that is at 0 degrees Celsius and 1 atmosphere. So at STP, 1 mole of any gas takes up 22.4 liters of volume. Any gas or hydrogen, oxygen, nitrogen, the 1 mole of any gas will takes up 22.4 liters of volume. So here we have the 1 mole of carbon dioxide will be given as 22.4 liters, because here it was given the carbon dioxide. So 1 mole of carbon dioxide is 22.4 liters. Then 3.80 moles of carbon dioxide will give how many liters? So now you have to find 3.80 moles of carbon dioxide. That means here you will be getting as a conversion factor. For volume you are taking 22.4 liters. Here you have the probability to same things. So 1 mole of carbon dioxide you can take as top, and 22.4 liters you can take as a bottom, and second you can take 22.4 liters as a top, and 1 mole of carbon dioxide you can take as a bottom. Here you see. So these are the two possible cases where you can take, but only we have to take one. And in the previous class also I explained about that one. So here 3.80 moles of carbon dioxide was there in numerator. So we have to find 3.80 moles of carbon dioxide. So the moles of carbon dioxide should be present at the denominator. This is your hint. 1 mole of carbon dioxide gas gives 22.4 liters. So here we have to take this one. So because the moles of carbon dioxide and moles of carbon dioxide will be get cancelled, finally you will be getting 3.80 into 22.4 will be given as 85.1 liter. So by using the same conversion factor, we can convert the volume in liters, and also from moles to liters and liters to moles. Next problem. How many moles are in 58.6 liters of nitrogen gas into at STP? So here we have to find the moles. So we know the 1 mole of nitrogen gas. So for any gas, the 1 mole of nitrogen gas is equals to 22.4 liters. Then 58.6 liters of nitrogen gives how many moles? That means now we have to find so 58.6 liters of nitrogen gas will give how many moles? So here you have to take the conversion factor. This is the basic formula. So 1 mole of nitrogen by 22.4 liters 1, and 22.4 liters by 1 mole of nitrogen. So this is one possible, and this is the second one, but we have to choose only the one. And always I said, so your liters are there in numerator, so denominator also you have to take as a liters, because liters will be cancelled, and you have to get as a moles. So here the liters of nitrogen gas and the liters of nitrogen gas will be cancelled. So 58.6 divided by 22.4 will be given as 2.62 moles. This is the answer for your problem. Next problem. What volume would 0.735 moles of oxygen gas occupy at 1 atmospheric of pressure and 0 degree Celsius. So we have to find the volume for the moles. So we know that 1 mole of oxygen is equals to 22.4 liters. Then 0.735 moles of oxygen will give how many liters? So here we have to take conversion factor that need to multiply for 0.735 moles, because he is asking you to calculate 0.735 moles. So here we have the two possible cases, conversion factors. So one, we can take 1 mole of oxygen by 22.4 liters, because this is your hint. Every time we will be getting an hint. With that hint we have to use your conversion factor, and this is your second one. 1 mole of oxygen by 22.4 liters and 22.4 liters by 1 mole of oxygen, but we have to choose only one. Which one you have to choose? Here it was given the moles of oxygen, so denominator should present the moles of oxygen. So this is your formula, because the moles of oxygen will be get cancelled and you will be getting as a liters. So 0.735 into 22.4 liters is equals to 16.5 liters.